So suppose we have to calculate variation of pressure with height. If density of the liquid varies with, or rather we can say density of the fluid, it may not be a liquid, density of the fluid itself. We can make it fluid, right? So for example, if density rho is a function of height, say height h from ground level, then how does pressure? Then find an expression for pressure. Variation with height. So we choose a, this is the ground level, and say at a certain height h, the pressure is p, and at this point density of the liquid is also rho. Rho is a function of h. Now, so after a certain height dh, that means at the certain height h plus dh, then the pressure will be p plus dp, regardless of whether the pressure increases or decreases. This is how you express a function. That means, say, if you express now y as a function of x, then at x the corresponding value is y, and at x plus dx the corresponding value is y plus dy. In the same way, at height h the pressure is p, at height h plus dh the pressure is p plus dp. Now we consider, say, a very small cylinder made of the fluid like this. So suppose the cross section is, say, alpha. Alpha is the cross section of the cylinder. Cylinder has a height dh. Now the forces from the top, the force due to pressure is p plus dp multiplied by alpha. From the bottom, the pressure is p multiplied by alpha, and the weight is dh into alpha into rho g. Now for equilibrium of the cylinder, of height dh and cross section alpha, what we can write, that d say dh, the weight dh alpha rho g plus p plus dp alpha is equal to p alpha. Therefore we can write rho g dh is equal to minus dp. Therefore we can write dp dh is equal to minus rho g. So this is the general expression for if rho varies, if the density varies. Now we can extend the same concept if the density is constant. If density rho is uniform throughout the fluid. That is, generally this happens for a liquid. So then we can write dp is equal to minus rho g dh. If you integrate, then say from height h1 to height h2, then p1 to p2. So you can write p2 minus p1 equal to minus rho g h2 minus h1. That is, p1 minus p2 is equal to rho g h2 minus h1. This is the expression we have used before also. P1 minus p2. That means 1 is at a lower level. This is the ground level. So you have a point 1 here and a point 2 here. Inside the uniform density fluid, mainly for a liquid. So that's height h1 and that's height h2. So we have p1 minus p2 is rho g h2 minus h1. That is rho g. Difference in pressure is uh, rho into g multiplied by the height, difference in the level.